Now, somewhat orthogonal to unit testing, integration testing, and system testing is a testing technique called differential testing. In differential testing, what we're doing is taking the same test input, delivering it to two different implementations of the software under test, and comparing them for equality. Differential testing is extremely powerful in the case where we have multiple versions. Stress testing is a kind of testing where a system is tested at or beyond its normal usage limits, and is probably best described through a couple of examples. So, for example, with a square root function that we were talking about earlier, we might test it with very large numbers or very tiny numbers. For an operating system, we might test it by making a huge number of system calls, or by making very large memory allocations, or by creating extremely large files. For a web server, we could stress test it by making many requests, or even better, by making many requests, all of which require the database to communicate with its backend. Stress testing is typically done to assess the robustness and reliability of the software under test. And finally, we have what might be my favorite kind of testing, random testing. So in random testing, we use the results of a pseudo-random number generator to randomly create test inputs, and we deliver those to the system under test. And sometimes we're just feeding raw random bits to the software under test, but very often this can be much more subtle and more sophisticated than just throwing random bits at the software. And random testing is very often useful for finding corner cases in software systems, and the CrashMe program for Linux and other Unix kernels that we talked about earlier is a great example of a random tester. And we'll talk about more examples later on in this course.